Let's walk through question number 1 here first. Okay, so in question number 1, we need to figure out first off what our givens are. Okay, they're looking for the number of moles, which is N. They tell us the material is calcium carbonate. And again, this is not how I would give this to you on a test. I would give the name and expect you to get to the formula, okay, because that's a step harder. All right, so calcium, we got 40.08. There's only one calcium. There's one carbon, 12.01, and there are 3 oxygens. All right, so to get our molar mass, we got to put those together. So 40.08 plus 12.01 plus 48, that's 3 oxygens. Okay, so 100.09 grams per mole. Okay, and then they tell us that we have 125 grams. So that's little m. All right, so that would be 1 mark. Okay, the mole equation is N equals little m over big M. I'm looking for N, so I don't have to manipulate. I just need to plug in 125 grams divided by 100.09, and I should get 1.25 moles. Well, I think it rounds to 1.25, does it not? Pretty sure it does. Okay, but we'll double check just for argument's sake. Okay. All right, everyone follow me on that. Okay, that's the easiest one. All right, because we know what we're looking for N. We don't have to do any manipulating. Everything else is given. Okay, there's really nothing else to figure out. Everybody with me on that one? Yeah. Okay. Try number 2. If you get done number 2, then try number 3. Okay, I'll go through number 2 here in a few minutes. All right, for question number 2, we're being asked to find the mass. So we are looking for little m. Okay, we are told that we have 2.7 moles, so that's N, of lithium phosphide. So for the molar mass, we got Li3P. So that's going to be 6.94 times 3 plus 30.97, right? Okay, for the phosphorus. Okay, so we have, Jess and Lauren, okay, we have a molar mass of 51.79 grams per mole. So now we know what big M is. We are looking for little m, which means I need to manipulate this equation by multiplying both sides by big M. All right, so that's going to be my formula. So little m will be 51.79 times 2.7. Okay, that's big M times N. All right, so we're going to have a mass of 139.83 grams. Oh, put a decimal in there. 139.83 grams. Final answer. Okay, questions on how number 2 worked? Okay, the next 2 questions are going to involve that extra step using Avogadro's number. Remember that Avogadro's number, okay, Avogadro's number is 6.02 times 10 to the 23. It's actually on that formula sheet thing that you have somewhere, okay, times 10 to the 23, and it represents the number of particles in 1 mole. Okay, so think about that when you're trying to find the number of molecules. Okay, this is the number of molecules in 1 mole. All right, if you want to find the number of molecules in more than 1 mole, there's a certain operation you have to do. Okay, let me give you a few minutes on number 3 here. So on number 3, we're looking for the number of molecules of iron 3 oxide that are in 230 grams. Okay, so first off, big M, Fe2O3, that's going to be 55.85 times 2, okay, plus 16 times 3. All right, so 159.7 grams per mole is our molar mass for iron 3 oxide. Okay, so our next thing here is now we've got also the mass, 230 grams. So even if at this point I don't know what to do to get the number of molecules, what should I find? If I have big M and little m? N, all right? But that's the next logical step. It's what I can find right now, even if I can't remember what to do after that. At least I know right now I can get some marks by calculating the number of moles. All right, so little m, sorry, was 230 grams. Big M was 159.7 grams per mole. Okay, so when I do this, I'm going to be left with moles. So 230 divided by 159.7. So we have 1.44 moles. Okay, so I have the number of moles, and I know that Avogadro's number is the number of molecules in 1 mole. All right, I have more than 1 mole, so what should I do with those two numbers? I should multiply them, right? Okay, so the number of molecules is going to equal N times Av's number. Okay, so that's going to be 1.44 times 6.02 times 10 to the 23. Okay, remember, we got to put that in brackets, use the exponent button, 23, okay? And we're going to get 8.67 times 10 to the 23 molecules. Okay, questions on that one? Okay, how important is it to show your work on a question like this? It's very important because it's easy to make a calculation error. It's easy to punch something in wrong, okay, and then as a result get the wrong answer. Okay, you get part marks for method, so you should take advantage. Okay, I have had students in the past who've told me I don't need to show my work. You're going to give me full marks when I get the answer right. They would say when I get the answer right. Okay, and I can't argue with that. I mean, if you get the answer right, I have to give you full marks. You're either an incredibly brilliant guesser, okay, or you legitimately knew how to do it. Problem: if you make a mistake, what am I going to give you? 0, because all you have is a number that's not right. Okay, and I had this happen to a kid one year in physics. He went into his final exam. He never showed any work throughout the whole semester. He forgot to put his calculator back in degree mode. Okay, showed no work and got next to nothing on any of the questions requiring trigonometry on the exam. Okay, it's a kid who should have legitimately got like 85 and got like 52. Okay, because they refused to show work. Show your work. It's really important. Everybody with me on that one? Okay. Okay, try number 4. Okay, so on number 4, we are looking for the mass of a given number of molecules. Right, so what we have to remember here is that if I want to calculate mass, I'm going to need number of moles and molar mass. Well, molar mass I can figure out right now because they did tell me what the compound is. It's nickel 2 nitrate. Okay, so figure that one out. So nickel is 58.69. There's only one of it. How many nitrogens are there? 2. There's only 2 nitrogens. Okay, so that'll be 28.02. And there are 6 oxygens. So 16 times 6. So 58.69 plus 28.02 plus 16 times 6. That gives 182.71 grams per mole. Okay, I need N, and I don't have it, and I don't have mass, so I can't use mass to get it. So what I have to remember is that the number of moles can be the number of molecules divided by Ab's number, because Ab's number is the number of molecules in 1 mole. So I'm taking the number I have, dividing by the number in 1 mole, and getting the number of moles. So that's going to mean 5.42 times 10 to the 21 divided by 6.02 times 10 to the 23. So I have significantly less than a mole here. Agreed? Okay, like I have like less than 100th of a mole, right? So I'm going to get a very small decimal. I think it comes out to decimal 009 or something like that, right? Okay, so decimal 009 moles. So I have a very, very small amount. Now that I have the number of moles, now I can use the mole equation. N equals little m over big M. I have N and big M, so I'm solving for M, little m that is, by multiplying both sides by big M. All right, so mass is going to equal 182.71 times 0.009. All right, so I end up with 1.64 grams, somewhere in that area. Okay. Okay, it's a pretty small amount. Questions on number 4? All right. On your unit exam, expect to have to do one of each kind. Okay. All right, we were working on this yesterday. Okay, so I want you to continue working on that. I think most people got to question number 2. Remember, this is also in the digital workbook. And just a minute ago, I posted the keys for all of these worksheets on the mole equation on Google Classroom. So if you want to check your work as you go, just go to Google Classroom and open up the PDF I just posted, and you'll be able to check your answers as you go. Okay, if you have questions or need help, just call and just put your hand up, call me over, and I will come and give you a hand. Okay? Yeah. So on number 6, it's not so much asking you about the mole equation, although it is making you do a small mole calculation. But what's more important here is that it's asking you, do you understand the difference between a molecule of oxygen and an atom of oxygen? Because oxygen is one of our special elements, okay, one of the molecular elements that pairs with itself, and in its natural state is not a single atom, but a pair of atoms. And a pair of atoms is a molecule. Okay, so the first thing we want to do is obviously do our mole calculation here. So they're asking how many oxygen atoms are in 64 grams of oxygen gas. Okay, so I've got 64 grams, that's little m. The molar mass of oxygen gas is what? 32. Okay, oxygen as a single atom is 16, but oxygen gas is 32 grams per mole. So the first thing I want to do is calculate the number of moles, because that's what I can calculate with the 2 pieces of information I have. All right, so I've got 64 grams, and each mole is 32 grams per mole, so it looks like I've got 2.00 moles. Everybody all right with that? Yes? Okay. So now, if I want to calculate the number of atoms, okay, I'm going to take this number, which is the number of moles of oxygen gas, okay, and I'm going to calculate the number of, am I calculating the number of molecules or atoms if I'm doing this? Molecules. I use the molar mass of a molecule of oxygen, not of an atom of oxygen. Everyone follow me here? Okay. If I wanted to find the number of atoms, I could have used 16. It's okay. I can still get to that in a minute. Okay. So I'm going to take my, I'm going to find the number of oxygen molecules by taking N and multiplying by Ab's number, the same as we would with any compound. All right. So I'm going to take my 6.02 times 10 to the 23 and multiply it by 2. Which is going to give me 1.204 times 10 to the 24. Is that right? I think it's right. Okay, so that's the number of oxygen molecules. How many oxygen atoms are in each one of those? Every molecule of oxygen has how many oxygen atoms? This is the part the question's asking about. This is a molecule of oxygen. How many oxygen atoms are in that? You guys looking at me like I'm asking you a trick question. 2. Everybody with me there? So I just figured out, you really thought I was trying to trick you. I'm not. That was a simple question. Okay, so this is the number of O2 molecules. If I want to figure out how many oxygen atoms there are, I have to multiply this number by 2. Okay, and then I'll have the number of atoms, because this is the number of molecules. There's twice as many atoms. Everybody follow? All that question is asking is, do you understand the difference between a molecule and an atom? Okay, that's really all it's asking. Okay. Now, number 7 is a similar question. It's asking again, what's the difference between a molecule and an atom? Which contains more atoms? A mole of iron, well, iron comes like this when it's by itself, or a mole of oxygen gas? Oxygen gas, because there's 2 atoms in every molecule, whereas this is only a single atom. Okay, so there'd be twice as many atoms if I had a mole of this than if I had a mole of that. Okay. All right, keep going.